All right, hi guys, this is the beginning of chapter 5. This is video number 20. This is chapter 5, section 1. And this whole chapter is about exponents and logarithms, but this section is about exponential functions. All right, so here's a brief definition for you. An exponential function is any function that can be written. Oh, that's supposed to be can. I started to write can and be all together. That can be written in the form y equals b to the x, where b, the base, is any positive real number other than 1. Okay, the other thing that you should know, while we are not graphing, you should know something about all of their graphs. Excuse me. So the graph of every exponential function has two things in common. The graph of every exponential function have two things in common. One, they all cross the y-axis at the point 0, 1. And 2, none can cross the y-axis or the x-axis. So just in general, an exponential, up here 0, 1, and this function might look like this, and it's going to come down real close to but never touch the x-axis, or it can actually flip the other way and come this way and come real close to but never touch the x-axis, and they always hit that point 0, 1, always. Alrighty. There's a couple other things need to know. E, it's a cursive E written like that. It's a button on your calculator that we'll talk about in a moment, is an irrational number. That means it doesn't ever end. It can't be evaluated exactly, kind of like pi. Irrational number that equals approximately 2.7183. And on your calculator, if you hit second and then the LN button, which you'll be learning about in previous chapters, that gets you the E. So above your LN, you see E to the X. And that's what you're going to hit to do that. If you were to type in your calculator E to the first power, it would tell you it's 2.7183, blah, 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 and it would just keep on going. Okay. The next thing you need to remember is that when you're dealing with exponents, we had a rule earlier on that said a to the negative m power was 1 over a to the positive m power, right? You flip your sign and put it underneath 1. So that's going to come into play. So we're going to do one problem here. Some of these are really straightforward in varsity. You don't need my help for those. We're going to jump into one that's a little more difficult. And then we're going to do some application problems, which I'm sorry, application or word problems. I know you all hate them very much, but those are actually the biggest place that these are used in real life, is in all sorts of crazy things. Decay, figuring out seismic activity, figuring out amounts in loans and interest rates and all sorts of different things. So we're going to be dealing with that. So here's the first actual problem that I want to throw in your direction. Let f of x equal 3 to the x and g of x, and g of x equal 1/2 to the x. Then evaluate f of x minus f of -3 all over x minus -3. All right, so you should recall from earlier that if you have something like this, f of -3, that means you're going to plug that value in for the x in that function, right? And f of x means just plug in the function. So f of x is 3 to the x, and then we're going to evaluate 3 to the x at -3, which means minus 3 to the -3rd power over x plus 3 because we have x minus a -3. All right, so now let's simplify. We have 3 to the x minus 1 over 3 to the 3rd. I was debating just putting 1 over 27, but I thought some of you might get a little bit confused. Okay, and then 1 over 3 cubed is 1 over 27, so 3 to the x minus 1 over 27 all over x plus 3. And that's all you're doing here. You can't combine any like terms. You can't solve for x. You don't know any information. So that's as far as you can actually go. Okay, the next one. One of the most common real-life applications of exponents is using the formula a equals p times 1 plus r over n all raised to the nt power. And this will predict how much money you will have in an account if you deposit a certain amount called your principal for a certain length of time. Oops. Sorry, typo. Certain length of time at a specific interest rate. Also recall, if you're dealing with percentages, if you're given something like 5%, that's actually equal to 0.05, right? You have to multiply that guy by 0.01. All right, so some information. The A is the final amount. I don't know why these little black lines are showing up in here. Something weird is happening in my software. I apologize for that. P is principal. The R is rate as a decimal, not as a percent. The N is the how much it's compounded. How often the interest is compounded. So if it says it's compounded quarterly, that would be 4. If it's compounded monthly, that would be 12. That kind of thing. Compounded, and T is time. Okay, so we're going to use that formula to work out a specific problem. So I'm going to write that formula at the top of my page, and then I'm going to give you the problem for that. So we have A equals P times 1 plus R over N times, or I'm sorry, raised to the NT power. Okay, so here's the problem. You deposit $500 into an account with an annual interest rate of 7%. And that is compounded quarterly. Okay. Use the formula A equals P times the quantity 1 plus R over N, all to the NT power, and round each answer to 2 decimal places if needed. Okay, so that's the information. And then this is a 4-part question. So part A is find an equation that gives the amount of money in the account after T years. Okay, so all we're doing is plugging in things that we know and kind of making a general statement. So we have the amount, the principal is the amount that we're going to put in. So we're going to deposit 500, and so our P equals 500. Here's some things that we can take from this equation, right? We have an interest rate of 7%. So the rate is 7%, but you're going to write that as a decimal, so 0.07. And then we know that this thing is compounded quarterly, and so your N is 4, and we're trying to figure out just a generic formula if you want to know over 2 years, 5 years, 20 years, 60 years, that kind of thing. So let's just fill in what we know. So P is 500, P is principal. Then we have our parenthesis. The 1 is not going to change. R over N. Well, we have those right over here. R is 0.07. Over N is 4. I'll color code these. And then we have raised to the NT power. Well, T is going to be a variable because we don't know. We're told in the problem we're looking for something after T years. And N is 4. So we want a 4T up there. And this is the answer to that question. Okay, B is really straightforward. Part B, it says, find the amount of money after 10 years. Okay, so all we're going to do here is use that above equation in the box. And for T, we're going to put in a 10. And then we're just going to plug it all in a calculator. So I have A equals 500 times, if you wanted to, you could do 0.07 divided by 4 and then add it to the 1, right? This part all in parentheses. And you would get 1.0175, all raised to the 4 times 10, which would be 40, right? So you can just plug this in your calculator. Make sure that you use appropriate parentheses where you need to. And the amount would be $1,000.80. Okay, so after 10 years, you've doubled your money with those stats in that problem. All right, the next part of this question says, how many years will it take for the account to contain 1,500? those of you who really want to take shortcuts cannot say, well, it took 10 years to double it, so it's going to take another 10 years to triple it. Can't do that. That is totally not how this works. So you at this point don't have the skills to mathematically solve this, but we can get it to a point where we can go and easily do some graphing and throw the information into a graph and then move from there. So we're going to take this. A is going to become 1,500, right? That's what we want to know. We started with 500 times 1.0175 raised to the 4t. Okay, so what we're going to do is divide the 1,500 by 500 and get rid of this leading coefficient here. So this will be 300 equals 1.0175 raised to the 4t. So what we're going to do is we're going to go graph this. And we're going to graph this. Y equals 1.0175 parentheses raised to the 4x. You need to use x and y when you're graphing. You can't use a t, so just change that variable. Okay, so I'm going to take you out to Desmos real quick and show you what this is going to look like if we graph those things. So bear with me here for a moment while I attach a keyboard and then get you guys out to Desmos. So we'll go here, Desmos. I use it so much, it's one of my pop-up tabs at the bottom. We're not actually going to the scientific calculator, though. We want to go to desmos.com. All right, we're going to hit Graphing Calculator. And then we want to graph these two equations. So one was y equals 300. Now that's going to be way up our graph, right? That's a horizontal line at 300. And then we're going to graph y equals 1.0175, close the parens, raised to the 4x power. All right, so that did not exactly do what I wanted it to do. Raised to the 4, do I need, I don't need that in parens. All right, let's go here. This is going to, I'm going to just follow this curve. We have to go way up high here. Maybe I can zoom in a little bit. There we go. Okay, so I'm just going to follow the curve. You can see over on the left-hand side of the screen where I am. So I'm at 100, 200. Here comes my 300 here pretty soon. Okay, so in Desmos, you can follow your screen, and then you can actually find the point of these two things and where they intersect. And if you hover over the top, it will show you what that's going to be. So they intersect at 82.194, 82.194 and 300. And so when we go back to our original equation over here, then we know that these two things, t has to be 82 years for this to happen, or x in this case, okay? All right, so that is how you can make that guy happen. All right, now the last part of this question, part D, is going to say, again, I have to get rid of my keyboard so I can write on my screen again. Sorry if this is noisy when I move the laptop around. I don't know how it comes across to you guys. All right, part D. I'm suspicious about that part. That just seems odd, that answer to number C. The last part says, if the same amount of money was compounded continuously for 10 years at the same interest rate, how much would you have? So when it's compounded continuously, those words are extremely important. That means that you actually have to use a different formula. And that formula is A equals P times E to the RT, where E is that value in the calculator we talked about. P is still principal. Your R is still your rate. And your T is time. And so if we started with our original $500 and we multiply by E times R and T, well, our rate, if you recall, was 7%, which was 0.07. And our time, we're going to say 10 years. So we have 10 times 0.07. And you just plug that straight into a calculator. So we're going to go 500 parenthesis, 500. E is second ln. And it goes, so E, your calculator does that. Make sure whatever you're putting in that exponent, you close the parentheses. So I'm going to go 10 times 0.07, close the paren, and hit equals. And I get $1,000. $1,006.88 if I round up. Okay, that's a 6. And so that's if it's compounded continuously, which means every single day it's compounded instead of just 4 times a year. All right, so that's how you would do those problems. And I think all the rest, there are some other problem examples, but I don't think you need me to model them for you to actually do them. If you do, make a good attempt. Try them a couple times in varsity before you reach out and grab some help. Don't just look at these and say, oh God, there's a lot of words. Oh, there's a lot of words. I don't want to do this problem. Just give it a try. I think you can handle it. All right. That's the first foray for us into exponential equations. Toodaloo for now.